Hey everybody, welcome back to another edition of Geometry. This is the day you have been waiting for. We're going to talk about trigonometry today. So this is section 8.4, trigonometry. So hang on to your hats. We're going to get going. This may take a little longer than a normal one. Normally I try to keep them at 20 minutes. So if you feel like your head's going to explode, just take a break, stop the video, go get some cookies and get a glass of milk and take a break and then come back. Okay, so let's get going here. If I can. If I can't, okay, I've got some new technology and it's being weird, so we'll see how this goes today. All right, our objectives. We're going to find trigonometric ratios using right triangles. And we're going to use trigonometric ratios to find angle measurements in right triangles. Okay, so that's what we're going to try to do today. All right, so first of all, what is trigonometry? What is a trigonometric ratio? Okay, so remember we have been talking about right triangles quite a bit recently, and so and remember we even talked about similar triangles. And so a trigonometric ratio is just a ratio of the length of two sides of right triangles. Okay, so for example, like in this first one here, we could say one ratio that we could talk about would be side AC over side AB. Okay, that's this side over that side. Okay, that's a ratio. Okay. And the point that we're getting at here is, since this is 35 degrees in this other triangle here, if it's also 35, then remember by angle similarity, we both have 90-degree angle, we both have 35. There are two angles that are the same. That means these are similar triangles. So if we have similar triangles, that means the ratio in the other triangle here is also the same, or will also be the same. So for example, DF, the ratio of DF over DE will be the same as the first one. Remember we did this with similar triangles. So the ratio of, say, AC to AB would be the same as DF to DE. There are other ratios as well, and we're going to talk about them later, but basically this is how these trig ratios will work. If you have the same, if it's in a 90-degree triangle and you have this one other angle that's the same, they're similar triangles, and you get all these ratios that will be the same for those. That'll always be the same. So as you can see here, by angle similarity, a right triangle will be similar to every other right triangle with the same acute angle. So we're going to get the same trig ratios. Okay, so this is what sets this all up. So here are the trig ratios. Whoa, Mr. Anderson, this looks crazy. Okay, it kind of does. I'm going to try to make it simpler for you. But let's talk about a few basic things here. The three trig ratios that we're going to be talking about are sine, cosine, and tangent. Now, oftentimes, when we write them out kind of shorthand here as we're working out problems, we'll write sine as S-I-N. Okay, this is not sin, it's sine. Okay, so when you see this written down, that's not sin A, it's not, oh, I've sinned. That's the sine of A. Okay, that's the sine of A. And then the cosine would be written as COS for cosine, and tangent would be written as TAN for tangent. Okay, so let me just go through this briefly, and then I'll try to simplify it in the next slide. So here's what they're saying is they're saying the sine of A, so the sine of A, we're talking about angle A here, big capital A, would be the opposite side over the hypotenuse. So the sine of A would be the opposite side. So remember, the opposite side, from where the angle is, you would go straight across. Okay, so this is the opposite side, would be A, as you can see up here. The hypotenuse is always the same. The hypotenuse is always the side that's across from the 90 degrees. So A over C. But if you notice, when they say the sine of B, now we're looking at this angle down here. Well, that ratio, that sine, would be, again, opposite over hypotenuse, but this time the side that's opposite of b is little b, and then the hypotenuse is c, so it'd be b over c. And then when you go to cosine, you'll notice the cosine of a is the adjacent. Well, remember we've talked about, used that word before. Adjacent means right next to. Okay, so if we're saying the cosine of a, what is adjacent? What side is adjacent to point A here? Well, and we don't, the hypotenuse is its own thing, so all we look at are the other two sides. Well, the only other two sides besides the hypotenuse are side B and side A. Well, side A is opposite of angle A, side B is adjacent. So adjacent would be B over C. Again, adjacent over hypotenuse. The cosine of B would be adjacent over hypotenuse, so the adjacent there would be A over C. And if you notice here too, the cosine of B was A over C, which turned out to be the same thing, excuse me, as sine of A over C. So the sine of A and the cosine of B are the same, and if you notice, the sine of B and the cosine of A are the same thing as well. So that's kind of interesting. And then lastly, the tangent is just opposite over adjacent. So the tangent of A, what's opposite of that would be A, little a, and adjacent would be B. Okay, so this is kind of the official thing here. Let me go a little bit more into this in detail and try to make it simpler. Okay, so you're like, how am I going to remember all that stuff? All right, there's, wow, that was really straight for being a mistake there. There's a little saying, and this is it right here, SOH-CAH-TOA, okay? And so SOH-CAH-TOA, when I grew up, I just kind of memorized SOH-CAH-TOA. However, in the meantime, I've come across another way that people have used to try to remember this, and I will pass it on to you. All right, so here's a kind of a little phrase that you can use, all right? Some old hippie, okay, and if you notice the so, S-O-H, it's some old hippie, okay, so there's the S-O-H, and I'll explain what that means in a second. Caught another hippie, and so there's the C-A-H. So some old hippie caught another hippie tripping on acid. Ooh, ooh. So tripping, T-O-A. So some old hippie caught another hippie tripping on acid. Okay, they must have come up with this in the 60s. But here's what this means, and here's, you know, I kind of went over a little bit in the last slide, but here's basically what this means. The SOH, if you can remember, SOH-CAH-TOA, the SOH means that the sign is always going to be the opposite over the hypotenuse. Okay, so there's your SOH. So in other words, you know, there's your SOH, sine is opposite over hypotenuse. Cosine would be adjacent over hypotenuse. And then the T would be tangent, would be opposite over adjacent. So these are the things here you can kind of remember. If you can remember this. Now it's going to depend on what angle that you're looking at, okay? And so this is what that last one was getting into, but it depends on which sign you're looking at for which angle, okay? So the first thing is, remember here, before we go into some examples, you're always going to be taking the sine, cosine, tangent of either this angle A or angle B. You are not going to do the 90-degree angle, okay? So it's always one of those other two. It's never going to be the 90. Okay, so that's the first thing. It's always going to be one of those two. And then depending on which one, so let's start out, let's look at A. Okay, so I'm going to circle A right now. So if we're looking at angle A, what side is adjacent to A. Remember, it's not going to be the hypotenuse. The hypotenuse is just its own thing. It's always hypotenuse. The thing that we have to make sure we know of, which one's adjacent, which one's opposite. So if we're doing A, side B would be, oops, I wrote that weird, adjacent. And side A, little a here, would be opposite. Okay, so if we're talking about angle A, this is adjacent, this is opposite, this is always the hypotenuse out here. Okay, now if I'm going to try to do this to make this a little bit better here, so let's go to get some red ink. So now if I go and I say, well, what about angle B? If I'm looking at angle B now, well, now for angle B, the side that's adjacent is this side here. So little a is adjacent. And what's opposite? Opposite is straight across from B, so this is opposite for B. And guess what? And the hypotenuse is always the hypotenuse. So that's still the hypotenuse. That didn't change. But when we changed angles that we were looking at, it changed which side was which. Okay, so that's really important. You got to pay attention to that. So it depends on which angle you're looking for. Okay, I think that's all we need to talk about there. Let's move on. So here's kind of our first step. Ooh, that's interesting. Look, my pen changed back to blue. Express the sine of L as a fraction and a decimal to the nearest hundredth. Okay, so we're looking at L. This is the angle that we're looking at down here, right? All right, so we have to figure out what's opposite, adjacent, and hypotenuse. Let's start with hypotenuse. That's kind of the easiest one to find because we've been looking at that for a while, right? So the hypotenuse, remember, is wherever there's the 90-degree angle, look straight across, here's the hypotenuse. So this is the hypotenuse out here. So that narrows down my choices for opposite, adjacent. It's got to be one of these two. Okay, so for L, what's opposite of that? Opposite is way over here. This is opposite. And adjacent is right next to it. And so what's right next to angle L is the side 35. So this is adjacent. So now we know what all these are. And so this is saying write sine of L as a fraction. Okay, well, the sine of L, so remember SOH-CAH-TOA? So remember the SO? That means your sine is going to equal opposite over hypotenuse. So we're going to say the sine of L would equal the opposite. What's the opposite side from L? 12 over the adjacent, or the hypotenuse, which is 37. Okay, so there. Now we would simplify that fraction if we could, but in this case, I don't believe we can. So there's a fraction, and then we'll just write it as a decimal. Now here's where I've got some new technology, and hopefully this is going to work. Good, excellent. Here it is. See what I've got here? I've got an online calculator, and so because we're going to get more into this in a little bit, then I'm just going to do 12 divided by 37. And so the decimal there, it said nearest hundredth, so we're going to call that 0.32. Okay, so that's all we're needing to do. Let me see if I can move that down there and keep it there. All right, so let's look at the next one. This is why it's weird. I think I have to like get rid of that calculator in order to move to the next slide. All right, so now we're going to do cosine of L. All right, so it's the same one, so it's still L. Okay, what's the hypotenuse? Same as before, straight across from 90 is the hypotenuse. Remember, the opposite is way over here, and the adjacent is right next to it. So if it helps you to kind of write those out, then that's good. Now, in this case, it's the cosine. So remember, the cosine was the CAH part of SOH-CAH-TOA. So that would be cosine is adjacent over hypotenuse. So in this case, we're going to say the cosine of L would be what's adjacent to L? 35 over the hypotenuse, 37. So again, if we could simplify that, we would, but here we can't, so we'll leave it like that. And then here I can just do 35 divided by 37. And you can see there, if we go to 2 decimal places, that's going to be 0.95. Okay? Kind of starting to get the feel for this a little bit? All right, let's look at the next one. Now it's the tangent of L. So remember, tangent is the TOA part of SOH-CAH-TOA. So that means the tangent would be the opposite over adjacent. Well, we're still looking for side L. And so you notice opposite, remember, was over here. Hypotenuse was here. Adjacent was here. So it's all the same. And so now we're going to say the tangent of L would equal the opposite side. So this time it's 12 over adjacent. So 12 over 35 this time. Again, if we could simplify that, we would, but in this case, just leave it like it is. And so then let's just type in 12 divided by, I didn't do 12. 12 divided by 35. So again, 2 decimal places, that's going to be 0.34. Okay? Now notice, again, we just did examples here with L, but if I went ahead and I did side N, or angle N, if I did the tangent of N, these would switch. The hypotenuse would stay the same. This would then be opposite to N, and this would be adjacent to N. So if we did the tangent of N, instead of 12 over 35, it would be 35 over 12. Okay? So it all depends on what angle you're looking at. All right, let's see what we got next. Special right triangles. Remember we did special right triangles in the last, on our last test. And we've got here one kind of drawn out for us. But remember there was a little pattern. So you kind of have to remember that. We, in this diagram that they've given us here, they're using X, where we used S instead. But if you remember, we used here S squared of 3, and 2S instead of the X. But it's the same idea here. And so we're going to tie some trig into this now. So what they're saying here is, let's use this special right triangle. We want to find the cosine of 60. So that's why we're using this 30, 60, 90 triangle. You got 90 degrees. If it says cosine of 60, the other one must be 30. Okay? And so remember, since we're doing cosine, remember what that is. SOH-CAH-TOA. CAH, that's the CAH part. SOH-CAH. So for the cosine, we're trying to do what? Cosine is adjacent over hypotenuse. Okay, so let's see. If we're going to do the cosine of 60, that will be the adjacent side. Well, here's the 60. So, well, first of all, what's hypotenuse? Let's start with the hypotenuse. That's always the easiest one, right? Here's the 90. Straight across from that, this is the hypotenuse. And 60, what's right next to 60? That's the adjacent side, which is X. And way over here, this is the opposite side. So if we're going to do the cosine of 60, we're going to do what? Adjacent, which is X, over hypotenuse, which is 2X. And then we're just going to simplify that. And so in this case, remember, if we have X, there's an understood 1 here, so we're just going to put that in there. It's like 1X over 2X. Hey, guess what? The X's cancel, and this just comes out to be 1/2. There's the fraction, which as a decimal would be 0.5. Okay, so you kind of have to go back and know these special right triangles. Here's another one. Special right triangle to express the tangent of 60. The tangent. Okay, so the tangent. Remember, SOH-CAH-TOA. TOA. There's tangent is opposite over adjacent. So to do the tangent of 60, that's going to be what? Well, that's the opposite. Well, again, we're looking at 60. So remember, opposite is over here. And adjacent would be here. And this would be your hypotenuse. So if we're going to do opposite, opposite would be what? X squared root of 3 over adjacent x. And then so what happens here? Oh, look at the x's cancel out. And so what I have left really is just square root of 3 over 1, or you could call that just square root of 3. It said there's a fraction. I guess technically this is still a fraction, but usually if we have 1 in the denominator, we can just simplify it to square root of 3. And then what's the decimal? Well, just take the square root of 3 here, and so you're just going to go, here's our square root button, is the second function right here, so square root of 3 then would be 1.73 there, 1.73. Okay, one more like that, 45, 90 triangle. So remember, in this kind of a triangle, remember our pattern there was leg, leg, legs times the square root of 2. So now it's saying do the cosine of 45. So that's the SOH-CAH, the CAH part, the CAH. So that means cosine is adjacent over hypotenuse. So the cosine of 45 would be adjacent. Now, in this case, it kind of almost doesn't matter, right? Because whatever 45 we pick, it's the same. So the 45 here, opposite, would be here, right next to it is here, and then this is the hypotenuse. So what is it? Adjacent over hypotenuse. Adjacent would be L over L square root of 2. And so remember, and again, remember, we're about to cross this L out, but remember there's always an understood 1 in front of a variable there. So when these cross out, we're left with 1 square root of 2. Oh, but you know what? We can't have a radical in the denominator, so I have to rationalize that by multiplying it by square root of 2, top and bottom. So this is going to give me the square root of 2 over 2. So here's our fraction in the form that we like it in, where there's no radical on the bottom. And then to get that as a decimal, just hit second function, square root of 2, close parentheses, divided by 2, and that's 0.71, we'll say it when we simplify that. So that would be 0.71. Okay?